yesterday when some people were doing the dot product, they did not have this dot here. Okay, they just had the two parentheses looking like they were right beside each other, which if they weren't vectors would mean multiplication, like from, like grade 9 when we were just multiplying integers together, that denoted multiplication. But because with vectors, there's two different products. There's one called the dot product that we learned yesterday, and today we're going to use the cross product. So you have to put a symbol in there saying whether you're doing the dot product of the vectors or the cross product of the vectors, and they're two very different things. That was the most common error on the assignment yesterday. Other ones were just mechanical errors, which are is easy to make them because there's so many multiplications and additions and everything to do there within a question. So that's just one thing I really wanted to make sure everyone knew. Okay, so starting with the cross product. So this is the second product we're learning about how to another way we can multiply two vectors together. We're learning how to find the magnitude and direction of the cross product of two vectors. So different from the dot product, the cross product produces a vector, which is really important to know. So the cross product of two vectors is a vector. Magnitude and direction of the cross product of two vectors. We're learning to find the cross product of two algebraic vectors, even more importantly, and learning to determine whether or not three vectors are coplanar and what that word coplanar means. That'll be the last thing we learn. So another product of two vectors exists. It's called the cross product or vector product. The cross product of two vectors A and B is a third vector, and this vector is called A cross B. So that's how you say that, A cross B. That vector happens to be perpendicular to both vectors A and B. And its magnitude is the number that represents the area of a parallelogram formed by the two vectors. So this is kind of interesting. So I'm going to do a little whiteboard thing here. So say I have vector A. Everybody see that? Vector A. And then I have vector B. And they're at an angle of theta between each other. So vector A cross B is going to be perpendicular to both of these vectors, okay? Perpendicular to both of them. So it's going to be going, if this is flat on my desk, A cross B is going to be going straight up so that it's perpendicular at 90 degrees to both vectors A and vector B, okay? So first of all, that. Second of all, the linear length of this yellow vector I'm holding up is going to be equal to whatever the area of this parallelogram would be if I formed a parallelogram out of my vectors like that. So if this ended up being, say, 15 square centimeters or square units, square centimeters, right, the area, then this vector A cross B would be 15 centimeters long, okay? So interesting definition of the cross product, really important that we know it's a third vector. So it only exists in 3 space because it's perpendicular to both of the original vectors. Cross product only exists in 2 space, or 3 space, sorry, in 3 dimensions. And it gives me this third vector perpendicular to the other 2. Okay, so that's our definition here. So it's a third vector A cross B, which was this one, right? That is perpendicular to both vectors A and B and whose magnitude or length is the number that represents the area of a parallelogram formed by the 2 vectors. The cross product only exists in 3 dimensions. The cross product has extensive applications in light and electromagnetism, if you're taking physics. First, we will look at the cross product of 2 geometric vectors in 3 space. So if A and B are 2 non-collinear, and you saw collinear yesterday in one of your practice questions. So what does non-collinear mean? So for instance, if we come back here, A and B are non-collinear, whereas I could draw, say here's vector C and vector D are collinear because they lie along the same line. Okay, so collinear vectors lie along the same line, or the angle between them is 0, whereas non-collinear vectors don't lie in a straight line and the angle between them is not 0. So that's what non-collinear means. Arrange tail to tail, forming an angle theta, where theta is between 0 and 180. The cross product is defined to be a vector with a magnitude and direction as follows. So the magnitude of vector A cross B is going to be the magnitude of vector A times the magnitude of vector B times the sine of the angle between them, instead of the cosine, which was like dot product yesterday. That's just the magnitude though, just the magnitude. And we know that A cross B is actually a vector, so we also need to know its direction. So this is geometric again. We're starting off geometric and then we'll move to algebraic vectors. So geometrically, the direction of A cross B has to be perpendicular to both A and B and follow the right-hand rule. And this is a physics thing. When the fingers of the right hand point in the direction of vector A and curl towards vector B, your thumb will point in the direction of A cross B. So here's how I'm going to show you this again. I'll show it here and I'll show it on my big one. So here's my right hand here, my right hand. My fingers are pointing in the direction of vector A and curling towards vector B, and my thumb's pointing straight up. So the direction of vector A cross B is going to be straight up, which is what we said here as well. So if my fingers of my right hand point in the direction of vector A, curl towards vector B, then my thumb points straight up, and vector A cross B is straight up or out of the page. Okay?
Now, what if you did B cross A?
Right, so here, perfect question, John. So B cross A, so in order to do that with my right hand, I have to turn my hand over so my fingers start off in B, curl towards A, and this time my thumb points down. So this time it would be into the page or down, depending on the way you've oriented it. I usually say if we're doing this into the smartboard or out of the smartboard, okay? So I'm gonna say out of the page or into the page. So A cross B is gonna be out of the page and B cross A is gonna be into the page.
So okay. I guess for the dot product where it might not have mattered, what order?
The dot, yes, the dot product is a number. The answer is a number, so it doesn't have a direction associated with it. Whereas the cross product, your answer is a vector, so it has to have a magnitude and a direction. And we're going to just deal very briefly with geometric, which is the right-hand rule. Once we find the cross product using algebraic vectors, the direction is just inherent in the vector that we get, because we'll get a vector that starts at 0, 0 and ends at what 3 numbers, and that will have the direction contained in it. So this is just, we're going to do a few examples of the geometric definition, and then we'll move on to algebraic vectors. So here's our diagram. So you have to be given a diagram, obviously, because if you have to give a direction geometrically. So in this diagram, it says the magnitude of vector A is 3 and the magnitude of vector B is 5, and theta is 30. Determine A cross B. So it's going to be, according to our formula here, the magnitude is going to be the magnitude of vector A. I'll write it out just because we haven't done this before, times the magnitude of vector B times the sine of theta. And then let's figure out the direction so we can write it in square brackets right away. So if it's A cross B, my fingers are going to be on A and curl towards B with my right hand. So it's going to be out of the page. So I'll just put out for my direction, which is going to be 3 times 5 times the sine of 30 degrees out, which is going to be 15 times sine 30. Sine 30 is a half, I think. Yep, so it's going to be 7.5 units long. That's how long the cross product is, and it's going to be out of the page. So does anyone have thoughts on how A cross B and B cross A are going to be related to each other?
Will they be the same, just different, opposite directions?
Yeah, do you agree with that? Because we're still going to be multiplying magnitude of B, which is here, magnitude of A, which is here, angle between them still 30 degrees, which is here. The only thing that's different is this time my fingers are starting at B and curling towards A, so it's going to be into the page. So B cross A is just going to be 7.5 units in to the page. And even when we're talking algebraic vectors, A cross B and B cross A are going to be completely opposite vectors. So if you know A cross B and they ask you for B cross A, you just need to switch all the signs on your components. All right, so that's geometric. I think we have one more geometric question up at the top of this page. So given two vectors U and V are arranged so the angle between them is 60 degrees, find, okay, so just the magnitude of vector U cross V. We don't care the direction this time, they just want the magnitude. If the magnitude of vector U is 4 and the magnitude of vector V is 7. So the magnitude of vector U cross V then is going to be the magnitude of U times the magnitude of V times the sine of theta, which is 4 times 7 times the sine of 60 degrees, or approximately 24.2. So that would be the length of the vector. All we cared about is length there, magnitude.
Would you want an exact answer on a question like that, or?
I feel like if you got this question, John, it would most likely either be an application or it would be a multiple choice. And then if it was exact, you could figure it out.
Okay.
Okay. All right, so now we're on to the most important part, cross product of algebraic vectors here. So it involves the determinant of a matrix, and the proof of that you learn in linear algebra if you're taking it in first year university, or matrix algebra, depending on the university you're going through. So we are going to use like a passed on, tried and true, like shortcut method for this. I'm going to show you the one that my high school teacher taught me. Mr. Cunningham teachers, when he used to, we both taught him a different way, but it was really very similar. So I'll show you. So this is a passed down method over generations. And then if you actually take linear matrix algebra, you'll learn the determinant of a matrix way to do it. So the reason we do a shortcut is because the cross product of vector A and B is, so the first component is A2, so this times B3, subtract A3 minus B2. Okay, so that's just the first component. And the second component is A3 times B1 minus A1 times B3. And the third component is A1 times B2 minus A2 times B1. And nobody wants to memorize that. So they came up with these little shortcut methods. And even when I learned the determinant of a matrix methods, I always used my shortcut because it was quicker. Okay, especially if all I needed was the cross product. So I'll show you how to get it. So you want, so here's going to be where my first component's going to be. So I'm always going to use, I'm going to use scrap paper for this one, but you guys can write it smaller over here. But I just want to make sure everyone can follow for this first time we go through. So when finding the cross product, it matters which vector you're told to cross first. So U cross V, I'm going to write out the components of vector U. So 1, 3, 2, and then I'm going to repeat the 1. Okay? And then below it, if I'm crossing it with V, I'm going to write the components of V, 4, -6, 7, and then I'm going to repeat the 4. And I'm going to start not here, but 1 in. Okay, so there's my starting place. And to get the first component, it's the downward product subtract the upward product. So for my first component here, I'm going to write 21 subtract negative 12. And then I'm going to put a comma for where my second component's going to be. Okay, and that will be A2 times B3. So here's A2 and here's B3. Sorry, my bad. Yeah, here's A2 and here's B3. A2 times B3 minus A3 times B2. So it does work. All right, so then we're going to move to the right. So for our second component, it's going to be downward product minus upward product. So it's going to be 2 times 4 is 8, subtract 7. And then I'm going to move to the start. And my third component is going to be downward product minus upward product, negative 6 minus 12. Okay, some people can do that. All those, they can just stare at this and get the 3 numbers. They don't need to show that middle step. If that's you, that's fine. There is a lot of signs, so be careful. 21 subtract negative 12 is actually adding, so that's 33. 8 minus 7 is 1. And negative 6 minus 12 is negative 18. So vector u cross v is the vector that starts at 0, 0, 0 and ends at 33, 1, negative 18. And remember, by definition, it's going to be perpendicular to vector u and vector v. And if we wanted to find its magnitude, it would be as long as the area of a parallelogram defined by u and v. All right. V cross U, we already said we know it's going to be the opposite of these signs, but let's just try it out because we're just learning. So if I was doing this, I would write vector V out first. So 4, negative 6, 7, repeat the 4. And then underneath vector U, 1, 3, 2, repeat the 1. Starting in the second space in, downward product minus upward product. So negative 12 subtract 21. And then I'd move to the right, downward product minus upward product. 7 minus 8. And then move to the right again, which gets you to the start. So that's 12 subtract negative 6. We're expecting to get all these components but negative. Let's see if that happens. Negative 12 minus 21 is negative 33. 7 minus 8 is negative 1. 12 subtract negative 6 is positive 18. So we did get it, even though we didn't just change the components, we actually calculated it out for practice there. And then the magnitude of vector u cross v. So that's going to be the magnitude of the vector. We've already calculated it, 33, 1, negative 18. And people are using the magnitude with the parentheses very well. Your communication's been really good. So now that I'm finding the magnitude, I'm going to say it's square root of 33 squared plus 1 squared plus 18 squared. Go to my calculator here. Giving me the square root of 1,414, which I don't believe is a perfect square, but I'll check. No, so I'm just going to leave it as square root of 1,414. Okay. Given vector A is 516 and vector B is -304, find vector A cross B and show that it is in fact perpendicular to both A and B. Okay, so we're going to find vector A cross B. So I'm going to write vector A out, 5, 1, 6, repeat the 5. And then underneath vector B, -3, 0, 4, repeat the -3. Start here, downward product minus upward product. So the first component is going to be 4, subtract 0. Downward minus upward. -18, subtract 20. Downward minus upward. 0, subtract -3. So A cross B is equal to 4, -38, +3. Any questions on how to get that cross product? Everybody's catching on to how you do it? Okay. All right, so that's the first part of the question, is to find vector A cross B. Check, hopefully. We want to show that it's perpendicular to vector A and vector B. Any ideas how I could show that this vector is perpendicular to vector A and vector B?
Could you use the dot product?
You can use the dot product. Okay, so that's what we're going to do, John. So we're going to see if it's perpendicular to vector A. So we're going to do vector A dotted with vector A cross B. Now, if I write that down, there's an order of operations that's understood. You always cross before dot, okay, unless there's brackets telling you otherwise. But you could see that if I dotted the A's first, I would get a number, because the dot product of two vectors is a number, and you cannot cross. You can only cross two vectors. You can't cross a number and a vector. So this is like, these brackets don't need to be there, but they're understood to be there. So I'm going to do vector A, which is 5, 1, 6, dotted with vector A cross B, which we found to be vector 4, -38, 3. And when I do that, if I get that A dotted with vector A cross B is 0, then I know that vector A is perpendicular to vector A cross B. So that's going to give me 20 minus 38 plus 18. Dot is multiply and add, which is 0. So that means, therefore, vector A is perpendicular to vector A cross B. Remember, this is a vector. A cross B is a vector. And then we want to do the same thing for vector B. So we want to see what vector B dotted with vector A cross B is. So vector B is -304. Dotted with vector A cross B, which is 4, -38, 3. So that's going to be -12 plus 0, 0 times -38, plus 12, which is 0, which means that, therefore, vector B is also perpendicular to vector A cross B. Okay, so we found vector A cross B, and we proved that it was perpendicular to both vectors, which is its definition. So question 3, given vector U and vector W, find a unit vector that's perpendicular to both U and W. So given vector u, I'm going to change vector w here to -4, -3, 0. We want to find a unit vector perpendicular to both vector u and w. Any ideas on kind of a plan for how we could do this question?
I guess could we like get the cross product and then
Yes,
find the unit vector of whatever the cross product was?
exactly. So the cross product is going to give us not a unit vector. The cross products will give us a vector perpendicular to both u and w. And then whatever vector we get for u cross w, we can make it into a unit vector by dividing it by its magnitude, and then we'll have a unit vector. Awesome. So first, let's find vector u cross w. So I'm going to write u out. Repeat the first one. Write w out below it. I know I'm starting here. So see if you can get those components so you can feel good, like I know how to get the cross product. See if we get the same thing. Careful with signs. Lots of negatives here. Did you guys get -9, 12, -26?
Yep.
Yes? Okay, great. All right, so now we want to make this into a unit vector. So I can't use u hat or w hat. It's not u hat cross w hat. That's not what it means. So I have to pick a different letter that's not in the question. Maybe I'll choose A. So A hat is going to be vector u cross w divided by its magnitude. So that's how I'm going to get a unit vector that's in the same direction as vector u cross w. So we just found vector u cross w to be -9, 12, -26. And its magnitude is going to be the square root of 9 squared plus 12 squared plus 26 squared. So 9 squared plus 12 squared plus 26 squared, 901. So then A hat would be the vector -9 over the square root of 901, 12 over the square root of 901, -26 over the square root of 901. So it's the vector that starts at 0, 0 and ends at point -9 over root 901, 12 over root 901, -26 over root 901. So that unit vector would be perpendicular to both vector u and vector w. So remembering that the definition of the cross product is that it gives you a vector perpendicular to two other vectors is really important to know. All right, question 4. If u equals that and v equals that, find the magnitude of vector u cross v. So this one's fairly straightforward. You're going to first find vector u cross v and then find its magnitude. So it's going to be 0 subtract -2 for the first component. 3 minus 0. Did you guys get 2, 3, 11 for U cross V?
Yep.
Yeah?
Yep.
Has anyone found they can go straight from like the graphic organizer to this step without writing out this one? Nope, we're writing out. That's good. I think you catch more mistakes if you write it out. Okay, so now we have to get the magnitude of vector U cross V, which is going to be the square root of 2 squared plus 3 squared plus 11 squared, or the square root of 134. Any questions about that one? Okay. All right, we're doing more these types of things here. So if vector A is 431, vector B is -202, and vector C is 1, 5, -5, then find each of the following. So the magnitude of vector A cross B cross C. Okay, so I guess I'd first find vector A cross B. So I'll have like whatever A cross B is and then cross with C. So I'd write A out here. Starting here. So 6 minus 0. Okay, so notice how that first parentheses represents vector A cross B, and now I'm going to fill in cross C, which is 1, 5, -5. And that's using proper communication, how my first step would look. And then I'm going to finish off vector A cross B here. So 6, -10, 6. Hopefully, is that what everyone got for A cross B?
Yeah.
Yep.
That's
Okay, so now what we're going to do is we're going to cross these two vectors. So I'm going to go down here because I think I can get away with that much room above to finish the question. So I'm going to write out 6, -10, 6, repeat the 6, 1, 5, -5, repeat the 1. Start here. So that's going to give me, the first component's going to be positive 50, subtract 30. 6, subtract -30. 30, subtract -10. Which is going to be the magnitude of the vector 20, 36, 40. So that vector there is the vector A cross B cross C. And we want its magnitude, which is going to be the square root of 20 squared plus 36 squared plus 40 squared. The square root of 3,296. So that is the magnitude of vector A cross B cross C.
Miss Northwood,
Yep.
you were saying before you could, I guess, skip the step where you're showing the subtracting or adding.
Yeah, so this could be your first step, John.
Okay.
And then this could be your second step.
All right. And that's okay?
Yep.
All right.
A lot of people are either really good at mental math or like really quick at using their calculator. They don't make mistakes. I like to write it out because as I'm getting older, I seem to make more mistakes. But when I was your age, I could do that. Even when I first started teaching, I could do that. Somehow I'm getting worse. All right, so the next one this is going to be a vector. We knew this was going to be a number answer because it was magnitude of a vector. This is vector A crossed with vector 2b minus c. And again, here's our order of operations. We want to find this vector, and then we're going to cross this vector A with whatever 2b minus c works out to be. So I'm going to write out vector A, which is 4, 3, 1. And I'm crossing it with vector 2b, which is negative 4, 0, 4. Subtract vector C. And notice this extra set of parentheses. A couple of people forgot that. I think it was in question 1C yesterday. So this is a vector subtract a vector, but to keep it all together, we need this extra set of parentheses here. So I'm crossing that with this vector, which is going to be negative 4 minus 1, so negative 5. 0 minus 5, negative 5 again. 4 subtract negative 5, which is positive 9. So now I've got it to where those are the two vectors I'm crossing. So I'm going to put that work down here. Okay, so 27 subtract negative 5. Negative 5 subtract 36. Negative 20 subtract negative 15. So 32. Negative 41. And negative 5. Is that what you got for A cross vector 2b minus c?
I think
Yep.
so.
Any questions for that one? Okay. All right, so question 6. Find each cross product I hat crossed with J hat. Anyone have a guess?
Is it K hat?
It is K hat. We'll prove it. But if you think about it, remember I hat's going to be, it's going to be right out of the page, but only 1 unit long, but I don't have really short pens to use. And J hat is going to be to the right. And it has to be perpendicular to both of them. So it's either going to be in the positive K hat direction or the negative K hat direction, because it has to be perpendicular to both. But if we want to do it and prove it, we can rewrite I hat as the vector 1, 0, 0, which is just important fact to know anyways. And we can rewrite vector J hat as 0, 1, 0. And then we can just do the cross product of those. So 1, 0, 0, 1, 0, 1, 0, 0. Start here. So it's going to be 0, subtract 0, 0, subtract 0 again, and 1 subtract 0, which is 0, 0, 1, which is k hat. Excellent. J hat cross k hat. So that's going to be vector 0, 1, 0 crossed with vector 0, 0, 1. We'll guess I hat, see if we're right. So 0, 1, 0, repeat the 0, 0, 0, 1, repeat the 0. Start here. So that's going to give me 1 minus 0, which is 1, 0 minus 0, which is 0, 0 minus 0, which is 0 again, which is I hat. K hat cross I hat is going to be 0, 0, 1 crossed with 1, 0, 0, 0, 0, 1, repeat the 0, 1, 0, 0, repeat the 1. Start here, downward minus upward. And we get 0 minus 0, 1 minus 0, 0 minus 0 again, which is J hat. And then I've got a little star or an asterisk beside D. And again, I want you to remember that whenever there's a dot and a cross, there's an understood order of operations that you always cross first. You always cross before dot. Okay, unless the brackets tell you otherwise, and then it would be a lot longer expression. But if it's just dot and cross, you always cross before you dot. Okay, so in this case, K hat is 0, 0, 1, and we're dotting that with I hat cross J hat, which we already know from this question is 0, 0, 1 or K hat. And then dot is multiply and add. So 0 times 0 is 0, plus 0 times 0 is 0, plus 1 times 1 is 1. So K hat dot I hat cross J hat is 1. So these are all, A, B, and C are all vectors because they were cross products. The cross product of two vectors is a vector. The dot product of two vectors is a scalar or a number. And that's a big, huge difference, obviously, between the dot product and the cross product.
So, Ms. Northwood,
Yep.
I guess for all of the ones where we were going, like, I don't know, up in the alphabet for the axes.
Yes.
Like I cross J, you get
Yep.
K. But if you were to do J cross I, you get negative K.
Right, exactly. That's a good point, John. So we know just by these being opposite that if we did J hat cross I hat, it's going to be 0, 0, negative 1, right? Because it's going to have all the opposite components, which is going to be negative K hat. So you can think of it as alphabetically. If you go the other direction, then you're going to get negative. Good point to bring up. All right, now we're going to learn something really important. And that's going to be the last thing we're going to tackle today. So 3 vectors are said to be coplanar if they all lie in the same plane. So I'm going to get my whiteboard up for a second. So you can think of my whiteboard as a plane here. And for all vectors to lie in the same plane, they don't have to start at the same spot, but it's going to simplify things for us to think so. But they all lie in this 2-dimensional plane, okay? So there's 3 vectors, okay? Now, one thing that's really important to know is that, let me get my other whiteboard out here. Oh, it's got writing on it. I'm just gonna erase that. Okay. Another thing that's really important to know about any 2 vectors is any 2 vectors are coplanar. So these guys, I wish I had a little more room in my camera. See how they don't look really, like they definitely don't lie on this flat plane right now. Does everyone agree with that? Just gonna move this stuff out of the way. But there's always a way that I can put them onto a flat plane. Okay, so I can find where they're similar, and then I can turn that over, and they're always gonna lie on a flat plane somehow. Okay, no matter how I can turn my plane around, I can always get 2 vectors. So here's a good example here where they're 90 degrees to each other. But if I put my plane here, like going up to the side of them, this would be better in a classroom, but if I put it going up to the side of them, I can flip it over and they'd be lying on that plane at 90 degrees to each other. So any 2 vectors are always coplanar. 3, no. Okay, so 3 vectors are coplanar if they all lie in the same plane. All right, so 3 vectors are said to be coplanar if they all lie in the same plane. Visually, you can think of it as they all lie on the same piece of paper, okay? So we're gonna look at a test for determining if 3 vectors are coplanar. It works as follows. So here we are back to my whiteboard here. So say I cross the pink one and the green one. Do you guys agree that I'm gonna get the yellow one-ish? It might be longer, but it's gonna be perpendicular to both green and pink. Is everybody okay with that? So if I call this vector A and this vector B, then the yellow highlighter I'm holding up could be thought of vector A cross B. Is everybody good with that?
Yep.
Yes? Okay. So now I'm going to call this one vector C. If I do the dot product of the yellow one, which is vector A cross B, the dot product of vector A cross B and vector C, if I get 0, then that means vector A cross B is also perpendicular to vector C. If that's true, then A, B, and C are all coplanar. Okay, so that's going to be my test. That's how the test works for whether 3 vectors are coplanar. I find the cross product of 2 of them, which is my yellow highlighter, and then I check to see whether the cross product is perpendicular to the 3rd vector. If it is, then the 3 vectors are coplanar. If it's not, then they're not. Okay, so that's where my 2 steps come in. Find the cross product of 2 of the vectors. If that cross product is perpendicular to the 3rd one, then they all lie in the same plane. And I've done my best to do like a little diagram there. So U, V, and W are all perpendicular to V cross W, so that means they're all in the same plane. And then if you want to take these 2 steps, I always do them separately, but if you want to combine them into 1 step, then you're really checking if U dotted with V cross W equals 0. That's a test. So you can think of this as the test that has to be passed. Here's our test for coplanarity. If U dot V cross W is 0. Okay, so Determine whether or not each set of vectors are coplanar. So the first thing I'm going to do, I don't use the test, but you can if you want to. I'm going to find the cross product of two of my vectors. I'm usually going to find A cross B just because they're given to me first. Because I know A cross B is going to be a vector that's perpendicular to both vectors A and B. So then off to the side, I'm going to write out vector A, and below it vector B, and start doing my cross product, which hopefully everybody is getting pretty comfortable with by now. So it's going to give me 6 subtract -3, 6 subtract 3, and -1 subtract 4. So vector A cross B is going to be 9, 3, -5. So now I want to see if this vector that I know is perpendicular to A and B is also perpendicular to C. So I'm going to find vector C dotted with A cross B. Because if their dot product equals 0, then we know they're perpendicular. So I'm checking whether vector C is perpendicular to vector A cross B by doing the dot product, which is multiply and add 72 plus 3 minus 75 is 0. Okay, so then I would say since C, vector C is perpendicular to vector A cross B, then vector A, B, and C are coplanar, meaning they all lie in the same plane. And then we'll try again with vectors u, v, and w. So again, my first step would be to find vector u cross v. So vector u cross v is going to be -2 subtract 10, -15 subtract 4, 4 subtract 3, careful, these are two negatives you're multiplying. So vector u cross v, I'm getting to be -12, -19, 1. And now I'm checking whether W is perpendicular to U cross V. So I want to find W dotted with U cross V, which is going to be 1, 4, -6, dotted with -12, -19, 1, -12, -76, -6, which I know is definitely not 0. It's -94. So since it's not equal to 0, since W, vector W is not perpendicular. Now, not perpendicular, there is a symbol for it. It's the perpendicular symbol with a cross through it. So not perpendicular to U cross V. U, V, W are not coplanar. So the not perpendicular symbol is just the perpendicular symbol with a cross through it. Okay, any questions about that? Okay, I'm gonna stop recording then.